All right, so this is the second part of section 1.3, functions and the representations. We start the second part with the four representations of a function, and there's four of them. We've seen three already. There's the graphical, which means in the form of a graph. Numerical, which, let me show you on the other page, is showing the numbers or the coordinates of the points. There's symbolic, which is in the form of an equation like these down here at the bottom of this page. Those are symbolic forms of a function. And verbal. And verbal is a description of the function. As an example, we might say the function, for example, grade level is a function of age. Yeah, that means the older you are, the higher grade level you're at. Yep. And we can give different values, like for example, when you're 6, you go to first grade. When you're 8, you go to third grade, or whatever pairings there are. All right, let's take a look at what sorts of things we need to be able to answer about functions. And so we're going to use the graph to answer these. Remember, it doesn't matter how it's shown. It can be shown in the form of a graph. It does not matter. And we'll do a couple. We'll do A and C. I'll do those here, and then we'll do the other ones in class. All right, so letter A says find the domain of G. The domain is the set of values of X, and that was defined in page 1. The set of inputs, right, or the values of X. That's the domain. And to find that, we go across the X-axis, because we're looking at values of X, and we check to see what values of X, if I were to draw a vertical line on that particular value of X, where does it intersect with the graph? And so if you look at -3, it doesn't intersect any points there. It doesn't actually start until -2. And so the start of my domain on the left is -2. And then any vertical line to the right all the way up until I get to +2 has a point where it crosses. And so the domain is from -2 to +2. And so I will write that from -2 to 2. And then do I include -2 and 2? Yep, there's solid dots there. So those points are points on the graph. All right. Number C, use the graph to evaluate G of -1. So that means they're giving me the value of X, and they're asking me to find the value of Y for that particular point on the graph. And so if X is -1, I check to see on the graph what's the value of Y that corresponds to X equals -1, and it's Y equals 3. So G of -1 is 3. And notice that means the point 3 comma -1, which is that point on the graph. Okay? All right. Let's go on to the others, B and D. We'll look at those in class, and you can do them before we get there. But I'm gonna leave them to get answers from you guys then. All right. Let's try. Let's take a look at finding the domain when it's something symbolic. And so, in general, the domain is all real numbers unless the function includes a fraction with variables in the denominator, like this one, or a square root or other even root, like this one. Even root would be like a fourth root or sixth root. All right. So these two then are going to give us some issues. Notice this tells us that in general, and we'll see later on that there's some other functions that we'll learn about, but they're kind of special, and I think we don't get to see them until chapter 5, where you see those functions. All right. But if we look at the first one, it does have a fraction, but there's no variables in the denominator, and it doesn't have any square roots. So we're going to say that the domain is all real numbers. So I'm going to say from -infinity to infinity. That's all real numbers. I can use the words all real numbers also. You might also have seen the boldface R, kind of like that, to represent all real numbers. All right, and then we're going to find f of 4. And so f of 4, that means that's the value of X. Notice we just place it in place of X. So f of 4 is 4 to the 4th minus 4 times 4 to the 3rd plus 1/2. So I'm going to plug in my 4 for X. All right, and then work it out. Okay, so this is 256. Notice this is 4 times 4 times 4 times 4. This one's actually 4 times 4 times 4 and then times 4. So that's minus 256. Plus 1/2, which is 1/2. So f of 4 is 1/2. Okay? If somebody asks us to find f of 4, we can just say 1/2, or we can say very... kind of like saying it in complete sentences, we can say f of 4 equals 1/2. And notice what that means is that the point 4 comma 1/2 is on the graph of this particular function. All right. And let's try number 7, and we'll leave number 8 as something that we'll do in class. And if you do it before, that's fine. We'll still see it in class, and we'll discuss it then. And we'll discuss anything else also. All right, so number 7, f of x equals 2x over x squared minus 9. Find the domain. So why is it that we have to be careful when the variable is in the denominator? Well, because there are values of x that'll make the denominator 0, right? And you cannot have denominators of 0. And we'll look at the square root also as far as, why is the domain not all real numbers. So what values of x would make the denominator 0? And we can guess them. 3 would be one value, because 3 squared is 9, minus 9 would be 0, right? And actually negative 3 is also would make x squared minus 9 equal to 0. And so we cannot have 3 or negative 3. And so we can say then x cannot be plus or minus 3. And I'm okay if we write it that way. Your book will sometimes write it in what is called set builder notation. So they'll say the set of all x such that x cannot be plus or minus 3. And what they're this is a formal way of saying that emphasizes that it's all real numbers x, but not plus or minus 3. Okay? You can also write this in interval notation, because if you're excluding plus or minus 3, that means you're including the intervals from negative infinity to negative 3, not including negative 3, union from negative 3 to 3, not including those, union from 3 to infinity, not including 3. Okay, so there's two different ways you could write this. There may be others. Actually, I think we actually said 3, but on this one you don't have to write it in set builder notation. Your book will. I won't ask you to do that. All right, and then find f of m plus 4. So f of m plus 4 means that the value for x will be m plus 4, and we're just going to plug it in. So this will be 2 times m plus 4 over m plus 4 squared minus 9. Notice the way I write it, I'll write parentheses and then I'll replace that with whatever the input is, m plus 4. I'm sorry, I won't replace it, but I'll put the input in the parentheses. M plus 4, and then you have to work that out, because, see, that might be a reducible fraction and you won't see it unless you work it out. Okay, so this is 2 times m plus 2. I'm going to leave that one as it is. But the bottom one, m plus 4 times m squared, is m plus 4 times m plus 4, and you have to work that out, okay, however you know how to work it. And we can talk about that if you need to ask in class. But the answer to that is m squared plus 8m plus 16, and then the minus 9. Okay, so I'm going to simplify, because 16 minus 9 can be done. So this is 2 times m plus 2 over m squared plus 8m plus 7. And then it turns out, and I don't know if you guys remember this word, factoring. We can factor that. Why do we want to factor it? Because one of these factors might cancel that one out. Okay, so it's 2 times m plus 2. When we factor m squared plus 8m plus 7, it's m plus 1 times m plus 7. Turns out nothing reduces, so that's f of m plus 4. Again, because we're just asked to find f of m plus 4, we can answer that, or we can say the complete sentence, f of m plus 4 equals that. All right, and finally, a hint on finding the domain of square root. So to find the domain of a square root, remember we have to find values of real numbers that will return real number values. That is, we cannot have an undefined number. And so what values of x would give us a number that would be whose square root is undefined? And what that means, and the way you can find out, is check to see what kinds of values of x, when you try to find the square root of whatever number you get, that your calculator says that's an error, you can't do that. Okay, so that's one way to kind of approach that. Or some you might be more familiar with these, and it's okay also. Alrighty, so I'm going to leave that one alone. I do want to tell you one other thing that's in this section, and that's there's some homework problems that ask you about implied domain, or use that phrase. And what that refers to is in real world applications, which you guys might call word problems, values outside the realm of possibilities are excluded from the domain. And so what kinds of values, what might those be? Well, like time less than 0. right? Doesn't happen. The length or the height of the length of a table, for example, or the paper here, less than 0, negative lengths can't happen. And there may be other things like more than 24 hours in a day does not happen. So if you're looking for the domain of something that happens in one day, or how many hours in one day, well, you can't go past 24. Okay, so the implied domain eliminates those values and just includes the values that are possible. All right, that's the end of section 1.3.